the lathe that this would be on is a straightforward 2-axis lathe, such as what you see here. And this is it's a straightforward Doosan Links 2-axis lathe. You've got your turret there, as you can see, on your slant bed at the back there, and you've got your single spindle on the left hand side in a totally conventional way. So we'll do a bit of work on that and see how we can set up a basic part, and I'll do some straightforward machining at the end of this webinar on this straightforward simple part. But also we're going to be looking at how we cope with a machine such as this. This is a Morisiki NTX 1000 machine with a twin spindle, a left hand side spindle and a right hand side spindle. You've got a turret at the bottom there that's on its own X and Z axis, and you've got a turret above here, this red thing that's tilted over. That's a turning and milling head, and it's indexable around a B axis, and it also comes backwards and forwards towards it, fore and aft on a Y axis. So we've got lots of things going on there on that machine. If I just bring up a little graphic here now. We don't have the lower turret on this little diagram here, so there's an extra axis on the bottom here to take into account. So you've got plenty of things going on there. You've got this Y axis on here, on this one. You've got your B axis rotate. You've got a Z and an X axis up there. You've also this sub-spindle that also tilts on its own B axis as well. So that could tilt upwards to face the B axis in a milling operation, whilst the lower turret machines on the main spindle. So complex stuff going on that just a few years ago would be almost incomprehensible, that you could have a machine that does all that, and then how the hell do you program all that and make sure everything works as it should? Well, the development of modern CAM technology makes it such that it takes a lot of the donkey work and the earache out of doing such a part. So first of all, I'm going to now go into the way we set this part up, and as you can see, this is a straightforward turning part, and it's going to go into a straightforward 2-axis lathe. So the first thing we need to do when we set this part up is give it our a coordinate. And we set the coordinate up according to how the machine is. So you'll see that on our model, I'll just zoom up a little bit into the middle of the model there. You'll see that we've got our Z-axis pointing along where the Z-axis of the machine would be, and we've got our X-axis pointing up towards our direction of our X-axis. This is our preformed. When you generate the part in SolidCAM, it gives you a preformed outline of the stock, and it also gives you a preformed outline of the machine part of the image there, the little wireframe there you can click on. So you can see that the X-axis is pointing in the direction that the machine's X-axis is in. In this case, it's got a Y-axis, but obviously it is ignored in any calculations that may be made in the SolidCAM calculation. It's just obviously you need to know where your Y-axis is pointing, if you had one. Okay, so this is as simple as it gets in turning. And if we look at our machine, if we look at our little second one down here, our machine, which is it forms part of your post-processor. Does this? This is a main part of your post-processor, and how it calculates values for the toolpath. And it's all based, well, a lot of it's based on the way the machine's set up. Now you can see here we have it's a straightforward machine, and we have a spindle, a tool spindle, and it's on it's got a Z and an X axis under it. That's our turret. Then we have our chuck, which is a C axis in this case. It doesn't have to have a value. You don't have to necessarily be able to control it. We've just designated it as a C. It's standard sort of where we do set these up. And so we've also got a parts catcher and a tailstock that moves and a bar feeder on this particular machine, but you know, these can be added if you have them, and obviously deleted if you don't. And so from these axes, from the spindle and from the X and Z axes that are on the machine, we have a sub-machine, which is basically a relationship of them axes. So you've got, for your sub-machine, you've got a Z, an X and a C, and that forms your machine. You've only got one machine, so you've only got one thing to worry about, and you've only therefore got one coordinate to worry about, and that would be the one that you've just seen there. That's how our machine is set up so far. Okay, so I'm going to just close this particular one down and open another example that would go with this likely sort of thing that would be used in our more complex mill turn machine, and it may take a second or two to open this because it's quite a complex model. I'm just going to sit my tea while it does so. Yeah, it's taken a few seconds, and here we are. Some of you may have seen this example of this model before. I like using it because it's quite complex. It's got everything that you can imagine, every machining feature that you may imagine that you would want to do on a machine. And this part can be fully machined as it is on one machine, on this particular one type of machine, this NTX 1000 machine. So yeah, very complex part, but it's fun to do. I don't know what the hell that part would do, but it's a fun part. So how do we set our machine up here? Well, let's have a look at how our machine's made up. You see, we've got our first axis set up as previously on the previous part, where you've got your X and Z, and in this instance your Y in line with the axes of the machine itself. So let's have a look at the machine itself. I'll just give you a quick reminder as to what this thing looks like. There's our left hand spindle, there's our right hand spindle, there's our lower turret, and there's our upper turret with the Y and the B axis also on there. So let's see how this equates in our VMID file. So what we have here, we have a series of devices. We've got our upper turret, and our upper turret has got just one station on it, as we saw, and the axes would be a Z1, a Y1, an X1 and a B1. So they're the axes that make up the upper turret. Then you've got the lower turret, and it's got 12 stations on it, and in there you've got a Z2 and an X2. So you've only got the X and Z axes on your lower turret. It's a standard type of turret. Then you've got your main spindle, and on your main spindle you've got the C axis, C1 we're calling it, and on your back spindle you've got a Z because it moves forwards, you've got a B because it tilts, and you've got a C because it rotates. So we've got a series of devices in our machine, and because we've got several devices, we need to have several sub-machines, because each of them devices has a relationship with each other. So therefore you have a relationship between your upper turret and your main spindle. You have a relationship between your lower turret and your main spindle, and so far with your upper turret and your back spindle and your lower turret and your back spindle. So we have 4 sub-machines. So each of them sub-machines has a set of the axes relationships there within their various sub-machines. So going back to our previous example where we had only one sub-machine, which is the one machine, here we have in essence 4 separate machines within the one machine, which therefore requires 4 separate relationships, which therefore requires 4 separate coordinates. So what we need to create, let's close this down, in our coordinate system manager, we need to create relationships for all of them sub-machines that we have. So I'll just rotate that back where I like it. So we have, where we've got highlighted here, our coordinate for our upper turret and main spindle. You see our Z is pointing where it should, our X is pointing in the direction of the upper turret, and the Y is in line with the upper turret's Y axis. Okay, I've also now then got a lower turret main spindle where the X is pointing in the opposite direction and the Z is still pointing in the same direction. The Y obviously is pointing in the opposite direction, but in this case the Y is less important because that lower turret doesn't have a Y axis on it anyway, so it's ignored. We're only interested in the X and the Z in this case. Okay, so that's the main spindle that's pointing in the in that direction. Now we'll look at the back spindle where we would have it at this sort of direction. If I put the next one on, which is the upper turret back spindle relationship, and we'll stick that on there, and you'll see that the X is pointing up again, up towards the upper turret. You'll also see that the Y is pointing in the correct direction for the upper turret, but the Z is pointing towards the job, which is still in line with the Z positive, which is the same direction as the front of the part, because obviously that is still Z plus, even though it's in the back spindle. You're still machining in Z plus when you take a metal off, and the same for the lower turret back spindle. So therefore we have now got our 4 MAC positions, separate MAC positions set up, because you've basically got 4 separate machines going on at the same time. So they all have to have their own coordinates on the machine, and these will equate to your various work offsets. You'll have your G54 for your first one, 55, 56, 57 for the rest, or however which way it is that you want the machine to be set up. You'll also notice that on the first MAC, under the first MAC position of upper turret main spindle, I've got another one that I've called angle holes. If I click on that, you'll see what that is. I'll zoom up slightly. You can see that I'm wanting to do an operation on here that means that I'll be drilling using the B axis on the upper turret. I'll be drilling these holes, and I'll be drilling them in a series around the diameter there, around that angled face. So because I want to do this in a 2D type of drilling operation rather than use the 5-axis mode, I need to give it its own little coordinate there, which I have done. If I was to do that in a 5-axis mode, then I wouldn't need to have created that coordinate. It would just rotate about its main coordinate. But I thought I'd just put that on there because if you were to do anything that requires any sort of manipulation in 2-axis where you change the angles or whatever, then you do need to give it a coordinate, an extra position under that same MAC. Notice that it's under the MAC that it's relating to, or the turret that it's relating to. Okay, that's enough babbling on about coordinates. I think we get the gist of that. So you've got 4 separate sub-machines within the one machine. They all have a relationship with each other. Okay, I'm now going to close that down, that part, and reopen our original simple straightforward part. Okay, just bear with me a second. Simple turning part, time for a sip of tea. Okay, here's our simple turning part back again, as we saw earlier. Okay, you can do all sorts as far as setting your part up. We've already set it up as far as our coordinate system is concerned. Our stock itself is already there and defined and being shown on the model. We've obviously extended the stock beyond the back of the model here because we've obviously got the grip on something on the chuck. So what else can we do there to help us? Well, first of all, we want to know, I would like to know where our jaws are. We're going to be gripping on these. I think when I'm machining this, what I'd like to do is to turn beyond the back face of here, just to make sure I've turned it off, so that when it comes to turning it round or parting it off or whatever I'm doing, I can go into onto a bit of cleanly turned part and make sure that I'm not, if I was to come to just the end, I would leave a little, your tip radius, leave a little rag on there. You don't want that neither. So I want to make sure that I turn beyond there, but I also want to make sure that I don't smack into my jaws. So it'd be nice to be able to see our jaws on there. So we can put a little clamping fixture on there. And there it is. It's there for us to see. I'll tell you what I will do. I'll edit that because it looks a bit flimsy. Does that jaw? Doesn't look like the jaws on my lathe anyway. Put it that way. So you can make these jaws a correct size, a correct value. So you can put your jaw width in there, your jaw height, which is your overall height, which might be there. It looks more like a jaw there, and you can also choose the position on your part there. The clamping diameter is 94. It's picked that up from the stock. It assumes you're gripping on the same diameter as your stock, whether it's a bar or a piece of billet or whatever it is. You can change that obviously, of course, if you've turned it round and you know you're gripping on the turned diameter, then you can obviously put that value in there. Click on the model. We'll give this a reasonable, straightforward depth there. So I don't know where it's picked that value up from, but I shall make that more straightforward. I'll make it minus 85 millimeters, and you can see it move. I mean, I'll do a bit of tweaking there. You can see it. You know, it'll go wherever you tell it, but I'll make it at minus 85. So that's straight away a it's got stuck. Have I put two minuses in there? Yeah, yeah. Minus 85. So obviously this is a setup value. You will tell the guy who's doing the turning and say, well, I've programmed it for sticking out of the jaws 85 millimeters. So there you go. You can exactly put it on the part as it is. I'll tell you what I forgot to do while I was doing that. I can generate an envelope here, and so that'll it'll keep that now when it's finished. It'll keep that now and add that to the drawing on the model there, so you can see that there live at all times, so that you know that you're not going to run into it. So that's our clamping fixture. So all I'm going to do now then, I've waffled on for 20 minutes about setting your machines up and setting your fixture up. As I said earlier, next week I'll be going more in depth to doing some more of the complex type of machining that you would do on the mill turn type machines, but we'll do some straightforward turning here. For people who are new to the turning module, or people who have not yet got the turning module and are thinking of buying it, it really is very straightforward. The only thing you've got to remember, or one of the main things you've got to remember, is that it works on stock at all times. It knows where your stock is at any time, and if you calculate something and it does something wrong, or it's not the way you intended it, there's two things that often go wrong for people who are just starting using it, and that is that you've not taken your stock into account, or your tool's not the right type of tool. Sometimes people forget to orientate the tool in the correct direction for the direction that they're cutting. Okay, with that in mind, I'll start an operation, and hopefully we'll be straightforwardly successful with it. Okay, so first of all, I'm going to add a turning operation, and I'm going to face off that front of that face, so to give me a nice clean face to then start turning. So my geometry, and you've got two ways of selecting your geometry. You can select by the wireframe that's being created here in SolidCAM when it was setting the part up, or you can use the solid model itself and just click on a face. I'll click on a face just to just for the hell of it, because I'll go through both methods of choosing it. In fact, no, I won't. I'm going to do it the other way around. I'll click on a wireframe this time, and then I'll click on the faces when I do the turning. So we're going to do a facing operation. I'll tell you what, I've clicked on the turning operation there. You can face in the turning operation, as you can see there, but what I'm going to do is use the actual facing strategy just so you can appreciate a little bit of difference there. So it is the facing technology that I'm using, and as I say, I'm going to use the wireframe method of picking the geometry. So I'll just click on new, and because it's looking for a wireframe, it's looking for a particular line, and the only line that I can pick to machine that face is that line there. The arrow is pointing in the wrong direction. That is the cutting direction. So I can just flip that by clicking on there to make it go down. And that is the only that is the only line that I can pick that's going to machine that face. But obviously that's the finish face that's on the model. What I want to do is I want to come from right up here at the outside of the stock, and then face beyond that and right to the center of the part. Well, you can do that quite easily. Once you've picked your direction line and the line that you're machining on, you can extend that line. Under the in our geometry menu, you've got the option to modify it, which invariably in turning you do want to modify it more often than not. So there's our line, and it's already automatically assumed that we want to auto extend it to the stock at the start of the line, and it has done so. It's ticked that box already. I didn't do that. And here we are. We can see that our line has been extended to the outside of our stock as it stands at the moment. It's always this stock as it stands at the time of you creating the operation. So if you've done any previous operations, it'll show you the stock outline as it stands at that point. So if you start to do some machining, and then you think, well, I'll change the order of them two cuts, and you swap them around, then obviously your stock situation is different for each one and would need recalculating. I know I bang on about that a bit, but it's something to bear in mind, that you are working with a constantly changing stock. What else I want to do though, because I want to machine to the center of this part, because it's a billet at the moment, I want to auto extend the end of my machining line to the stock, which is the center line of the part. So ticked on that, you can see the yellow lines extended to the center. Now I'm happy. That's exactly what I want to do. So I'm going to pick a tool, and I think there's a couple of tools in this library. Yeah, I'm going to pick this turning tool here. The direction isn't correct on there. Can you see the way that's held? And that's not the right orientation. And you can see it on the image. That's not the correct orientation for this part. So we need to change that orientation there. What I want to do is have a turning tool there, a tool that's capable of both turning and facing this part. So I don't have to use two separate tools. If I chose, let me see, where am I? This tool here, that would probably also do the job, but me being me, I like it that way. I like it the traditional standard turning way. Alright, I can't see the tip, it's a backwards facing tool, but it matters not. That's the orientation of the tool for the image of this part. You could have a tool which is a left-handed tool where you've got the tip facing you, but for this part, this is what the image is going to be. Okay, so I've picked out a tool. I've called it my facey turny tool. So I like things like that. And there we are. We've picked it, and we've got our orientation here. And this is what I was mentioning earlier on. if something's going to go wrong when you're doing these calculations, and you're thinking, well, that's not right, just check the way that your tool is first, because people forget to put the tool in the right orientation when they're picking it. And you can see our graphic there. That's how our tool is going to be orientated in the tool post. Okay, I'm not going to bother with any feeds and speeds or anything like that. I'm just going to show you how to basically get toolpath on the job. But in here, obviously, you've got your feeds and speeds and your date, and you've also got your any coolant option that you want to switch on the machine, whether it's through coolant or whatever. So next thing is our levels, which basically is in turning is safety distance. It's nothing to do with any levels that you like in milling, where you would be coming from and to, etc. Our technology this time, it's a facings technology, if you remember. So all you can do is either face on the front of something or face on the back of something. Well, we're facing on the front of something. It's already picked, as you can see. It's already highlighted, and we're working on our stock area. And we're going to go one way, because can't go two ways on a facing operation, otherwise you're going to damage something. And we're going to rough it out, and then we'll probably do a finishing cut as well with the same tool. So here we are roughing it out, and this method here called stairs, well, you've either got stairs or smooth. Smooth would be where you back trail on yourself. Well, there's no need to back trail, because we're cutting into the centre of the part, which is fresh air anyway. And we're going to then finish it. So on our roughing operation, we're leaving an offset of 0.2 on the face, and we're going to then finish it. At this point, you can choose whether you're going to use your cycle, roughing facing cycle, or also whether you're going to put compensation on. Whether it's a negative X output, we're not going to be doing that on this machine. So we just need to, sorry, I'll just go into link. Link is our lead in and our retract. The link is any movement that's not a cutting movement. So you're approaching from the right hand safety corner, you're going to go back to the right hand safety corner and lead in and lead out. I'm not going to put any on here. I don't think I need one, because it creates its own clearance anyway from the job. So it should be enough. If it's not, then obviously you would select a lead in to machine 2. Okay, so I'll just save and calculate that, and I'll just hide my menu for there for a second. Now I'm just going to put the tick box in this empty box there, and you can see our toolpath has been put on there. That looks good. It looks so far so good. So you can see it's approaching from the outside of the stock, and it's going to face down. I'll tell you what I didn't select was my step over. I'm stepping over. I left 2 millimeters on the front of this job, by the way, so it's going to step over at 1 millimeter. I'm leaving 0.2 on, so first step's going to be 1 millimeter, second step's going to be 0.8, then it's going to take the 0.2 off with the finish. I don't need compensation on this operation, because it's a facing operation. I'm not doing a contour, so it doesn't need compensation on it, but that's where you would put it for your finishing operation. Okay, so what does that mean in reality? Well, let's have a simulate, and I'm going to use the turning mode, because it's the clearest thing for turning. The turning mode, believe it or not, is the clearest way of seeing what you're doing. So I shall just quickly single step this. There's our tool. There's our red line. That's the red line that I picked. That's our geometry line that I picked. But obviously I've extended it up to the stock and down to the center. But that is our actual contour that I picked at the beginning. So what it's going to do, it's going to face off 1 millimeter right to the center. It actually goes beyond the center. Can you see that? It goes beyond the center by the value of your tool radius. It automatically does that. It automatically calculates that your tool radius is taken into account when facing to the center, so that you don't leave a pip on the in the middle of the face. Then it comes off by a small amount, predefined, back up to the outer, moves in, and it faces off that other 0.8 value there, leaving, as you can see here, 0.2 on the face for your finished cut. Moves off, comes out, does that 0.2, and it takes your final flick off to clean up, and that's it. Operation over. Job done. Okay, it's 3 minutes past 10. I did say this should last half an hour. If you're quite happy to hang on for another 10 minutes or so, 5 or 10 minutes. I'll just do the turning operation. I know you're all busy on a Friday, or you're either all busy or you're all waiting to go on because it's Friday half day. Wish it was my half day. Right, I'm now going to do a turning operation. So I'll close this one down. I'll take my toolpath off so it's off the screen, so it's not confusing us. And I'm now going to add a second operation. I'm going to add a turning operation, obviously, and I'm going to go into turning. Now, there's several things you can do in turning. You can either turn on the outside of a job, turn on the inside of a job, and you can still actually face back or front of a job. So what we're going to be doing is obviously turning on the outside diameter of a job. And the first thing we need to do is pick our geometry. This time, as I said earlier, I'm going to use the solid option. So click it on solid and then click new. And what it's showing us here is our green stock outline again. And can you see our stock outline has now changed? Our line at the front, our green line at the front, is now moved from where it was, 2 millimeters, because we've already faced that off. So it's already showing you where your stock now is. So it's wanting me to pick some solid geometry here to create this with the geometry line. So it's wanting me to start from a face or an edge or a vertex to an end face or an edge or a vertex. Well, what I'm wanting to do is I want to start from here, face 21, and I want to finish on here, face 12. And can you see now it's created this little green outline all the way along the outside of the job from the face that I clicked on, well, between the two faces that I clicked on. So I'm going, yeah, I'm happy with that. Thank you very much for creating that for me. And it's now accepted that, and it's in red now. That is our geometry line, and the direction is correct also from the direction of travel. So that's fine. I'm quite happy with that. Thank you very much. Okay. Now you can modify the geometry if you so wish, and I do so wish, because what I want to do is I want to travel slightly beyond the end of that diameter there. So we've already got auto extended to stock switched on, because it automatically does that when you go into modify, and you can see that the value in auto extend to stock is 0, because we're right at it, we faced it off. That face there is touching our machined face that we've machined off, so there's no stock on the front of it. But what I want to do is I want to extend beyond, slightly beyond the back face here. So I don't want to obviously auto extend to stock, because that is inside of the where your jaws are. So we don't want to do that, otherwise we'll be having some sort of accident. But I'd like to just go beyond there by, say, 3 millimeters. And as I type that in there, you'll see our little yellow line is extended beyond the end face there by 3 millimeters, and you can see that it's well clear of the jaws there, so we're quite okay there. So I shall save that now. I'll pick my tool, and I'm going to pick the same tool because that's my facey turny tool, capable of both facing and turning. So same tool, so therefore we shouldn't need to have a tool change or anything. I'll select that. Straight into technology this time. You know what the levels does. You know it's just a retract, etc. and a lead in. Sorry, not your retract. It's just your safety distance. Okay, our modes now. What we've got here is a bit more strategy going on than just the facing operation. We're able to rough, semi-finish, finish, and we have a little strategy tab there as to how we're going to go about things. So in here, we decide what our work type is. Are we going to rough it? Are we going to just do a copy the profile? Or are we just going to finish it only? Because you can obviously rough it previously and then finish it later, but I'm going to rough it here. And then, yeah, I'll finish it with the same tool. So if I was to click on finish only, you see our roughing tab's disappeared. So you know, if I click on rough, we've got our roughing tab here. So these options here, these are our modes that I mentioned earlier. You can either turn long external, internal, face, front, face, back. And we choose whether we're going to use our roughing cycle as well at this point. You can use your G71 or whatever it is on your machine for your roughing cycle, should you so wish. Okay, we're going into roughing, and we are going to choose our stepping down value. I'll put 2 millimeters in there because I'm feeling brave. 2 millimeters. And we can choose to use equal steps also. We can also choose to adaptive step down. Now what I mean by adaptive step down is that if I've chosen a step down value of say 5 millimeters, when if I come to turn this outside diameter, I'm telling it in one breath to take say 2 millimeter steps, and then I'm telling it also to leave 0.6 on the diameter. So it'll adapt your step downs so that any diameter it gets to, it leaves 0.6 on. So it may not step down 5 millimeters because it's got a diameter to leave 0.6 on. So that's what I mean by adaptive step down. If you took that off, then it would step down at your values there, and it wouldn't leave your 0.6 on your diameter because you've told it to step down by a certain value. Yeah, I hope you follow me on that one. If ask any questions, if you not sure about what I mean, you can ask a question at the end by pressing the hold hand up button on the graphic there, and typing something into the box, and I'll hopefully see that and answer at the end of the session. Okay, back to the task in hand. So what I'm telling it to do now is, as I said, step down at a value of 2 millimeters, and we've got a retreat distance of 0.2 just as it comes back away from itself, and we're telling it to leave 0.6 on the X diameter and 0.2 on any of the Z faces. We're going to travel in one way because it's a turning operation. We're just going to go one way. It's not a double-sided tool or anything that enables you to go both ways like a grooving tool. So I mean, most things are going to be one way in turning. So that's our roughing operation sorted out. Now we want to do our finishing operation. You can do a semi-finishing operation if you so wish, but I'm not going to bother with that. I'm just going to go straight for a finishing operation. And you've got a couple of options actually in your finishing operation. You can use you can use no, of course, and not do it, or you can choose the ISO turning method, as you can see, or the stairs method. Now if you look at our little graphic in the bottom left hand corner here, where the direction arrow is just pointing constantly in the one direction of travel, so you would just follow the contour along in the Z minus direction. That's your ISO turning method. Or you've got the stairs method, which depending on the shape of your job and material and so on and so forth, or just because you're in that sort of mood, you may want to do the backwards turning direction down faces or down angles, as the graphic now shows you, where you would come off at a face and hop over it and come down backwards. There's certain circumstances where you would that method would be preferable, but what you've got to bear in mind there is that you're coming away from the face and you're blending back into itself, so it may not give the best of results there. So ISO turning method is what I'm going to use here because it's straightforward shape is this part. And I'm going to do something here, and you'll think I've made a mistake, but I'm not. I'm going to do it on purpose, just because I like to show you something go wrong. But I'm now going to what am I going to do? I'm going to put compo on there. That's it, because it's our finishing cut. We are going to go up that angle there, so we need compensation on there to take into consideration our tool nose radius. Link, once again, I'm not going to bother with the lead in, lead out, because it should take care of itself on this particular job. Should be fine. I'm going to save and calculate and get rid of that. And I'm going to put my toolpath on now, and there you can see our cuts going over the part there. Now then, has anyone spotted the obvious mistake that I was talking about? Can you see it there? Maybe it's not. If you have, then good, but if you haven't, you'll see it now when I do it in the graphic simulation. So I'll just zoom up on there. Hang on a second. Let's go back. Actually, let me do that again because I've lost myself. Simulate that in turning mode, and I'll zoom up on the whole shebang actually. So I'm going to do it one step at a time, at the beginning at least anyway. And so here we are, well in front of our face, and we're turning along there at a diameter. Now that's not a 2mm step down, I don't think, but what it is doing, it's leaving the 0.6 on that diameter, because we've told it to adapt its step down to leave 0.6 on any face. And you can see that that next step down is definitely bigger than the first one, so it obviously did adapt its step down. One thing I forgot to mention in my technology, I chose the smooth machining operation, not the steps, not the stairs one, so that it back trails on itself up the angle there and allows you to have a nice smooth finish, so that when you come along with your finishing cut it doesn't whack into them all them big steps. So I'm going to let that continue. I'll do it automatically, and you'll see what happens when it gets to the last cut. Hello. Right, okay, so can you see what it's done there? It's gone into that groove because it knows it can, because of the angle of the tool. It knows it can dip down in there a little bit and clear out a bit of that groove, but that's of absolutely no use to man nor beast, is that little bit of digging in there. It's going to, in fact, it's probably going to hinder you when you come to do your groove. So let's just have a look what's caused that, or what we can do about that. Going to technology, we've got a little tab here called strategies. And hey ho, here we have a little option where we either tell the tool that it can go in any descending motion like that, where it can, if it finds a groove or a pocket or whatever, it can go down in there, or we can tell it not to. So obviously the idea is to tell it not to go down there. I'll resave and recalculate that, and you can see now that our graphic has changed, and I'll just simulate that quickly just to quickly show. I say quickly, come on, get on with it. And you can see now it's just gone straight across that that area there, hasn't gone into it at all. So it's completely just turned as normal, so that you can get on with your grooving operation. Okay, there's some simple turning. It took a little bit longer to do this webinar than I intended, because I do like to waffle on a bit. But I hope I got my point across with the way you set things up, and the ease of which you can set things up, and how SolidCAM can take into consideration more complex machineries with multiple axes, like 9 or 11 axes. And next week I shall go on to explain how we then put some toolpath on a more complex type of machine, so you don't need to be sort of thinking to yourself, flaming hell, my boss has just bought me this 9-axis machine, how the hell am I going to program it? Well, in SolidCAM it can be really quite straightforward once you understand the basic principles of how you set the machine up, and that the fact that you haven't actually got just one machine in there, you've got maybe 3 or 4 machines that all have separate relationships with each other. Okay, I'm just looking now to see if anyone's asked any questions, and I can't see any. I can't see that anyone's asked anything as yet. I'll wait a couple of seconds to see if anything pops up there. But if you have asked a question and I have not answered it, or because I can't see it, then you please email me at les@solidcamuk.com, or just call the office or email the office or whatever. Yeah, I hope you enjoyed the webinar. We'll be doing another webinar. I'm not sure whether it's going to be next week or the week after, but there'll be more in this series of webinars, and I hope you attend and tune in for those. Okay, well, nobody's asked a question, so all it remains for me to say is thank you very much for attending, everybody, and I hope you did enjoy it, and I'll catch you next time. Have a good weekend. Thank you very much. Goodbye.